Okay, and welcome aboard. So we are into Matter, and that will mean that by the end of this session, then you will have Living Systems and Matter posted to the website. And again, we'll show you where that is in case you've forgotten or not sure. Just a reminder too that the Moving Forward website is closing down at the end of the month. So we've already moved almost 90%, if not more, over to the new site. So you'll still have access to everything. It just has a little bit of a different look, and you just need to get used to navigating through it, and you'll be able to find all the things that you had before. So my name is Chris Sarsky. I am one of the consultants with the CARC Consortia, and I have the absolute pleasure of working with Ted, who is a brain when it comes to science and unpacking the absolutely incredible concepts that we keep throwing at you in your face and saying, these are the real important pieces. So I'm going to let Ted introduce himself, and then we're going to get going.
Hi, good afternoon, everyone. I am Ted Zeroni. I'm with the Edmonton Regional Learning Consortia. It's a pleasure to be here with you today to help move you through this organizing idea. Thank you very much for being here on near the end of the school year. It's very busy, and I'm sure you have lots on your plate. So thank you much for being here.
All right, so for those of you who have been through some of the series with us before, you know that usually when we do the acknowledgement, we either have a video in here or we have some bit of information that kind of links to where it is that we're starting. And in this particular case, instead of having a video, I've given you links at the bottom here that have direct links to the document that I took this from, the actual print document. But in here, what we're looking for is how do we, when we talk about the lens of science, how is the lens of Western science? In other words, our views the same and different from Indigenous views or lens of science. And so on the left-hand side, you see kind of what are the uniqueness of that Indigenous lens. Over here, we see what are the unique parts of a Western view of science, but we have a lot of common ground in between. And that's the important piece that we want to also remember is that students in our classrooms, all of our students need to see themselves in the course that we're teaching. So this gives us a way to look at where are the commonalities, but also what are the important differences. When I talk about how I interpret something, we look at parts of a whole, they look at everything holistically. And so how would that be different when I explain something in a classroom? So again, just something for you to look at. All the links for the resources and the sourcing is below that. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So all of our sessions, if you were with us with Pilot, you saw that we kind of had a very similar design. We're changing these up a little bit. Almost every organizing idea, we say, oh, we should maybe do this, or maybe we should do that. So you are seeing a little bit different than you did in Living Systems. We actually think it's getting better. Every time we do this, we get better. But in any case, we're always going to give you a background, or in other words, because it is a spiral curriculum, we do need to know what were the big rocks, what were the concepts that lived in previous grades that the students should have learned already prior to showing up at my doorstep next year in grade 5 that they won't have. And so there is some back building or bridging that will need to happen there. And so wherever possible, not without giving you the whole slide deck, we'll give you bits and pieces of whatever other grades that come previous to yours contain information. So maybe just jotting ideas down as we're talking. I need to go check this, or I need to go check that. You have full access to every grade. And so if you need to go back and grab anything, you're more than welcome to do that. We're going to talk about those surface, deep, and transfer, the concepts and how we've been unpacking, no different than we did in the pilot, but even more so targeted now. And how do those relate to the concepts that we're looking at? So really, what are the big rocks? What are the parts that are just straight facts? And what are the pieces that I really have to make sure that they've got those facts for so that I can take them deeper into making sure that they meet the understanding? We'll give you resources wherever I can find resources. Ted's got resources. So together we've been looking for places that you can go for resourcing in the absence of having sort of a one set resource that you might be working from. And then we do have a link for the computing science from Ange Deering, and she will go through and give you specifics about how would I as a grade 5 teacher take matter with the cusps that I have to unpack and infuse computing science. So it should be very targeted about just what you're doing in grade 5. And Nicole will offer the same thing. Nicole Amro will be offering the same in science, in scientific methods. So let's have a look at kind of what's been happening before here. We're still talking about properties, and that word property showed up really early on. And the kids really need to know that term. And again, hopefully as we go through today, we'll help unpack the differences sort of between what is a property and how do I describe it? Because that's a bit of a confusion for some students, and definitely we want to make sure that they're clear on that. And there's no difference in how that was sort of started in the previous grades to where they are today, just as important. So that term property went right back actually to grade 1 and in kindergarten even, but then we really unpack it more when we talk about materials, when we talk about change, transfer, and these are happening in grade 3. So we talk about the states of matter, which are really relevant to what you're doing in grade 5, which also came from grade 4. So not just what are the states of matter, but now we want to talk about what are some changes that are going to occur, and physical changes, and what would that look like? And then that builds directly into grade 6. So those are the pieces that we're going to have a look at. Again, if you think your students aren't really clear on materials, what's an object, what's a property, what's a material, then you might want to just have them watch this quick video here, which unpacks a variety of different materials so that we start to learn about what are they talking about when they talk about materials, and what are the properties they unpack, what are the properties of each of those materials, and how do I describe them? Those are the other pieces. So when I talk about properties, I'm talking about, is it soft, is it slippery, can I bend it, can I break it? Those are malleable, is it transparent? Those are the properties of the different materials that the students are starting to examine, and then they draw conclusions from. There was sort of a reference sheet here that we provided with all the different sort of testings and different opportunities for them to use properties and materials on. This is not hyperlinked, but the link is just located at the top right-hand corner here. And so if there are any here that you feel would be better for them to go through before you actually start on what you're going to be covering in grade 5, then again, please feel free to use those. Talking about man-made materials versus processed materials, and that they understand that a processed material comes from man-made materials. Again, looking at what can an environment look like that is natural. What do we look at when an environment is man-made? And even a city isn't 100% man-made. There are natural environments that live with those. Depending on where you live in the city or what city you live in, some of them have huge green spaces that are very natural. They were not planted. These are the native plants that came, and they just never got bulldozed down when something got built. So again, can students see that both of those can live side by side as well? We talk about those states of matter. If the students aren't familiar with those, and they may not be if they're coming this year, if this is the first year that you're actually doing the optional implementation, then they wouldn't have necessarily got a ton of background in this. So this is a great video that will go through all of those different states of matter and talk about the characteristics of each and how would I tell them apart. We've got some resources here that are mentioned. Some of them get used as well in grade 5 because they're really, really actually very applicable to both grades, or in some cases 3 grades. But you've got some books here. Solid or Liquid is another one, and it is very relevant. The latter parts of the book are very relevant for grade 5. And then there's also the graphic library series, which is States of Matter in this case, which is done as a graphics, not a graphic novel. It's a magazine style book, but it covers the states of matter in depth, and through a little bit of sort of an exciting superhero that goes through the whole thing too. So kids do like that one. And from grade 4, we really talked about when we have those different states of matter and we have different properties of all of these different materials that we've looked at in substances. What are we doing about making sure that we are looking after the earth? How are we looking after the degradation of some of those when we just fill landfills, for example? What are we doing to the environment? And now that I'm filling the landfill and I know a little bit about some of those properties, what am I doing about making sure that they are degrading in a safe and healthy way? How do we deal with the world of plastics? How do we deal with this picture of pollution that's up here? So you really start to unpack that in a big way in grade 4, but they have to have that background knowledge from before. They've talked about waste management. That is their focus. They've done recycling already in a number, 2 different grades for sure in depth. So again, if you feel that they need some little background knowledge with that, then you might want to go back. In grade 4, they talk about how do you deal with waste management, for example. And I'm not going to go through all of these, but each one of these 4 squares has its own slide and has its own information and its own unpacking. So again, if you need to go back and have a look at them, you'll see here that recycling, these are the pieces that we're looking at. There's a number of different links in here. And so you can just go through and see which one is it that we need to spend, or all of them we need to spend a bit of time on before we launch into what we're talking about in grade 5. Okay, same thing here. How do we deal with the plastics problem? How do we deal with one of the videos that's on there? There's lots of videos in grade 4 that they can use. But one of them talks about, well, the people that used to take our garbage don't want our garbage anymore. So now what do we do? What do we do with all that resource that we say that we're recycling, but there's really no place for it to go. So we're not recycling to send away to have somebody else use it because it's too expensive for them. So what do we do about that? And then we also talk about hazardous waste. Do students even know what hazardous waste is, right? So that's a first starting point. And once I know what it is, what do I do about it? Like, how do I get rid of it if I'm talking about waste management? And what are the safety symbols that we would use around safe waste management? So your WHMIS symbols would come into play here. Okay, we talked about a number of different possibilities. These are, again, depending on how you've unpacked it. These were some of the questions that they could ask. It could be, again, formative, or if reframed and it's a brand new scenario to them, could be a summative. Again, that depends on you and how you've unpacked it. And we've included in here also, and it's in your file folder as well, a rubric. So some of the schools were asking for a common scoring rubric that they could use. And this one comes from the Ontario Ministry. They just rewrote their science curriculum as well. And so they have a 4 level that they use throughout. There's a number of pages to this. It's not just what you see here. But if you're looking for something to have some common language and you don't want to design your own, this is just an option. Definitely not a must do, but it gives you something to start from. And then the number of resources that we talked about with them. These are the Max Axiom ones, the superhero guys. Recycling also had ones, looked at water. That's an important one. Water will come back again when we talk into Earth systems in a big way, and in energy. And then minimizing our human footprint. That was kind of the whole talk about the waste management. Like, how do we do that and still have a healthy Earth to come back to? Okay, so those are resources. So let's go into grade 5 and I'll turn it over to Ted.
Thanks, Chris. I'd like to begin with this slide. It should be familiar to most of you who are with us with pilot sessions. We showed this graphic to you quite a few times. And again, if you had seen our recorded session 1 that Chris was referring to earlier, you would have seen this graphic as well. And I want to quickly review it because it's this graphic and this approach that Chris and I are moving forward, and I'm going to use the word unpacking this curriculum with you. So we're looking at this curriculum and how can we teach it at the surface level, move to deep, and then move to the transfer level. The surface level is just that area or that time of our teaching when we teach students the individual concepts they're going to need for the understanding. And it's more than just the definition of the concept. It's really understanding the concept, being able to provide examples of it, non-examples. Teaching the skills at the surface level are looking at the verbs in the skills of procedure, deciding, well, what skills are the students going to need in teaching this cusp line, perhaps, that they're going to need to know in order to demonstrate their learning. So it may be comparing and contrasting. They may be good at it, we're not too sure, but you'd be doing some pre-assessments to find out how good they are at the skills that you're going to use at the end of in the summer, or the assessment part of the learning that happens. So you want to make sure kids are comfortable with all those. And then we get to the deep, we're talking about putting those concepts together in statement of understandings. And those understanding statements are listed in that middle column in our curriculum. In this particular organizing idea, I think there are two. Very knowledge-based curriculum. You're going to see the understandings are really grounded, almost a knowledge piece in themselves, but we can work with relating things in that. And then finally, we get to the transfers, really just getting kids an opportunity to using what they know to do, those skills, and understand in new and novel situations. And those could be our assessment pieces as well, once we know they're good along that way. So what we're going to do is we're going to begin with the surface level, and that's where we talk about the skills. Remember, it's not the whole skills and procedures statement. It is just that single word that introduces or starts that statement. So it could be something like sort, or it could be a specific skill like sort, compare, contrast, design, or it could be a procedure. And the key procedure in science for sure is found in scientific methods. We'll talk about that later, but that's the investigation process of asking a question, making a prediction, collecting data, and so on. There's a procedure to an investigation. So we want to make sure at the surface level, if we're going to have students investigating and I'm going to call it a unit of study, then we'll want to make sure that they know these things up front. Same with, I'm going to go to the next slide. I think I have a list of the skills, or not, maybe not yet. No, I'll have to show that at the end of the presentation. So at the surface level, again, we're taking a look at those concepts. What are essential to the understanding and the learning outcome? And we're calling those, or using those as the word concept with them. And a concept is simply that organizing idea, one or two words like fruit, that has many examples and non-examples. And we could see that concept appear in many contexts. And it's those individual concepts that we then put together to create the understanding. Go to the next slide, Chris. And it comes to the concepts. What I've done is organize the key concepts into a concept map for you that might be helpful in understanding the organizing idea as a big picture. And can help you sort of map out where you are. They look fairly complicated to read on the screen, perhaps, because it's kind of small. But when you download the PDF, to which you'll have a link to, you can read it in the following way, and it would begin at the particle theory of matter. I'm having trouble reading it, so just a second here. The particle theory of matter states that particles are held together by attractive forces, basically, which determines their state. We go to that purple word, and their state is based on the particle movement and the particle arrangement. So if we're in a solid state, then the particle movement would be vibrating in place, and the particle arrangement would be close together. We're talking about the state of a liquid. The particle movement is that the particles slide past each other. In a liquid, particle arrangement is there's increasing space between the particles. And then finally, in the final state, gas, when it comes to particle movement, they're in constant state of motion, moving in all directions, and the particle arrangement is that there are large spaces in between the particles. And of course, matter has its physical properties such as mass, density, and volume and compressibility that we're going to be looking at in this organizing idea. That pretty much sums up the key ideas and concepts in this organizing idea, and hopefully gives you a big picture of what we're looking at in this organizing idea as well. I'm showing this graphic again, just to highlight the idea of those concepts that we are pulling out and having students understand in a deep level. It's really important to do that because they do show up in the spiraling curriculum. As Chris mentioned, the word property begins early, and as early as kindergarten, and you can see it showing up all the way around to grade 5. We start with observable properties in kindergarten, and then we get to measurable properties, testable properties, and finally we're adding the adjective physical properties on at grade 5. So to know what that concept is quite important. Same with states of matter. We take it in grade 3, and then we see it again in grade 5, and we work with that understanding in grade 5 and as well in grade 6. So the spiral nature of the course means that we really have to consider what came before us as teachers when we're teaching this course, and what are the big things to really make sure students have a good handle on as they move forward into the next grade. So as I mentioned, we're going to unpack this in the way of how do we prepare for it, how do we prepare teaching for this in a way that looks at that surface, deep, and transfer approach. And at the end of the day, what we're really doing, you may be familiar with that term, understanding by design or planning by design or backwards planning. That's essentially what we're doing. We're really beginning with the understanding because we want to know that's really going to be the focus on. So we have to start with that. And then we have to take a look at and start with that, and then we'll work backwards. And we'll do that together with you in the first cusp line here. So we're going to be taking each cusp line and approaching it from that surface deep learning. So how we can get from the surface parts to the deep part and then do some assessing with it. You'll notice I have 2 things identified there. If we take a look carefully, the understanding is there is really a knowledge-based one, the original. That's why I have it kind of sliding to the knowledge. It's really it's really just what is the particle theory of matter? Well, it just basically helps explain that particles behave in certain ways in matter. And really, it seems that the understanding, the intent maybe is what is written in the skills and procedures statement, which is really that attractive forces have an impact on particle movement and particle arrangement in solids, liquids, and gases. So the forces in matter really dictate how particles move and how particles arrange, which determines whether they're solid, liquid, or gas. That seems to be really the understanding that we're trying to get at here. We're going to work with that, so we're not going to mess up, but we also work with that top understanding that's going to come through. But nonetheless, we're planning for surface deep transfer. We want to take a look at the understanding and highlight what are the key concepts in the understanding. Do we see them in the knowledge piece as well? And we could see that the highlighted concepts do appear for the most part in the knowledge piece. You'll notice that particle arrangement and particle movement doesn't appear as separate concepts, but you can see them sort of hidden in there when we're talking about the particles of matter have spaces between them, for example. That's how they're arranged, so that they're always moving, and that's how the particle movement is talked about. So nonetheless, when we take it surface, we got to highlight all those things. Sorry it took so long in that part. And we'll go to the next slide to show you what I mean when we talk about using it at the surface level. So all those concepts that I pulled out are ones that we want to make sure students understand before we even start putting this all together and explaining the whole particle theory of matter. And if we're going to be looking again, that's whole planning by design, if we're going to have kids represent their understanding, or they're going to be relating the concepts together or describing them at the surface level, we want to make sure that they know what is expected when they're going to make a description, for example, when they're making relationships, or if they're representing. So we'll want to do that all at the front end. And so what we're going to do is take you through some possible activities that might help you or help anyone to teach these things at the surface level, at the beginning level. So go ahead, Chris. I think you've got some examples here.
So as said, those terms that are sitting there, it really is a knowledge piece. I mean, this is, you'll hear me say at one point, I said it to Ted, I was looking for something that was hands-on, because it's a little too dry just to make this straight knowledge. But I need to know this as a student first. Even hands-on isn't going to mean anything if I don't know the meanings of these, right? So that'll be important for them to get that unpacked. And so there's all kinds of different ways that we can do this, but just as a sort of an upfront, these were kind of the explanations of some of the key pieces of the understanding. So it's really just an info board more for us, more less for the students. But looking again at some of the activities that could be involved within this entire organizing idea. We're going to unpack these, but I just listed a bunch down here because really these are the key pieces that they need to walk away with at the end to say, yeah, they've got these, or no, there's a few here that we really need to work on. So in starting, first of all, I need to even understand what is the particle model or particle theory, depends on which resource you're going to use, of matter. Like, what does that mean? And what does it mean to have molecules? And what does it mean that they're vibrating and that they're actually attracted? So those are the terminology pieces. So I'm giving you lots of resources here, but you don't necessarily have to use all of these. It's just really wanting you to have an option of places to go. But this one to start off with would be a great place. And it's actually a university professor for a university course. But such detailed time, and it's all very appropriate for grade 5, to show them with his finger as he moves the molecules. So to start with, if I really want them just to get a sense of what's the difference between a solid, a liquid, and a gas, once I've already understood what those are, this would be where I would start. And then this one really gives you, the descriptor is below here, does a great job of giving them examples very much at a student level. So this opening slide might be a good place for us just to even allow students to watch without asking them to give me terminology yet. And maybe you use that to draw out the terminology. What did we hear? What did we learn? What did we see? What do we come together on now? What this particle theory is talking about. So using the video to draw out from them what they've learned, and then we can fill in the gaps, as opposed to maybe giving them all those terms and stepping them through what they mean before I actually see what they are. So just again, sort of that backwards design model. Again, if I'm looking at just wanting to, I've unpacked it with them. We know what the three different states of matter are. We've unpacked
Particle theory
maybe
states
what the
that all
molecules
matter
look
is made
like.
up of
Sorry,
tiny particles that
what the molecules look like, and why are they packaged so differently? Why are they so dense when it's in a solid as opposed to in a gas, right, where they're so widely put apart? So again, can they explain this to us? Whether they can do deposition and sublimation isn't absolutely critical, but I included them. They're not part of their terms. But really, we live in Alberta. Alberta has frost. So why don't we name it? Why don't we let them see what it looks like and talk about it, right? Or why don't we talk about what are some possibilities when a solid goes straight to a gas? So again, those are still a bit above them, but just because it's part of what actually happens in the particle theory, I've included them in there as well. Okay. This one will go through, again, the states of matter and how they apply to the situation. And once I've watched all these and once we've talked about them, you know, I could ask them a simple question like, why is it easier for me to take a nail and push it into a piece of styrofoam than it is to push it into a block of wood? Explain that to me in terms of the particle theory matter, right? So why is that? Why is that happening? Why can I drop it in water and it just drops to the bottom? Whereas if I put it on top of a log, it bounces right off, right? So again, just having those application types of questions for them to start thinking about in terms of what they can realistically touch and see. What do you have in the classroom that would allow them to do that? What do they have readily available to them? What could they do outside that would allow them to demonstrate that understanding? There's a couple of resources. You're seeing them as we come through, but there's one in particular. This comes from a series called Science Flex. It's written at 4 different Lexile levels. Every student would get basically the same information, only just if they're having difficulty reading, they would just have a slightly less. But in this case, it just unpacks again, what are the different states of matter in terms of how the molecules are moving within each of those. And it's got a lot of great information in it. I'm really impressed. It has lots of places where they give them everyday types of jobs that would allow them to identify where those different states of matter and those properties are showing up. And then also it gives them an opportunity to expand a little bit more in each one of the different ones. So how do the solids, particles within a solid, what are the different kinds of solids I could investigate? And remember, as we move into grade 6, we're going to talk about phase changes. So it's really important that they understand how this is connecting in grade 5. Again, there's another resource. We showed this to the grade 4s, but again, I'm a big proponent of Venn diagrams. I love it when kids can show me what similarities and differences are with the things that they've learned. So what are some similarities and differences between a solid and a liquid, or a liquid and a gas, or a gas and a solid, or all three of them? Right now, in terms of what we know, they all have particles, they all have matter. So same thing, right? That would be one of those pieces that we would have access to. So again, this resource comes from one of the books that we've been looking at for you. It's called Changing Matter. If I was going to buy a couple of books just to have them in my in-class library, or in the library itself, this would be one, because this one really covers your curriculum exceptionally well. So just maybe have a look at some of those. But again, we're going to hopefully see some of these posted to New Learn Alberta. Describe the impact of attractive forces have on movement and arrangement of particles. So maybe I'm ready to do some questions. Maybe I want some newer opportunities for them to look at where these are going to be applicable. I was looking for some hands-on approaches. And so if you go in, click on this link here, this has several different components to a lesson. With each component, as I look at each of the different states of matter and the particle movement, there's interactive links in there for the students. But this is very much a hands-on approach. So if you are looking for something just to solidify that thinking with them, I suggest using this. This is excellent, and it actually works for your entire organizing idea. So again, just one of those pieces. Okay, just having a look too in the chat box here. Everybody's asking about where we're going to find these. You'll find them, and I see that's been put in. It's on the ARPDC site. We will take you there at the end to show you where you'll find all of your resources, any videos, anything that you need. That's where you'll find them. Okay.
So Chris just went through a whole pile of really cool activities to help have students understand those knowledge pieces, those concepts we're talking about, such as states of matter and so on, and how things work together in the particle theory of matter. As I mentioned, if we were to imagine back to that slide that had the surface level things pulled out, we had the green words highlighted on the right-hand side, meaning that we're going to have students do some activities to help deepen their understanding. One of those is to represent our understanding, build relationships between the concepts or ideas, or describe something. So I'm going to talk about representation shortly here in the next couple of slides. Description is fairly straightforward. There'll be a lesson area, some thoughts you can click on with an approach called the concept attainment activity approach. But I'd like to just walk with you through a concept attainment activity to get a sense of what it feels like, and how you can create your own or add to them or change the ones you have access to here. And I'm using this relationship one because for one reason, it does show up in the outcome. It's one of the verbs in the outcome to relate ideas together, and building relationships between concepts or individual ideas is really the whole crux of the understanding. When you look at the understandings, as we pointed out in session 1, the understanding is composed of all those individual concepts that are taught at the knowledge piece. So now we're taking them and we're going to put them together into a relationship. But to introduce kids at the surface level, what does that really mean? Sometimes the concept attainment is handy. You can use these any way you want. You change them to make them suit your class, your focus, or just use them to help you out to get an understanding of things. So the relationship one goes through this. Those are the steps. All the slide decks will have the lesson steps, so that if you want to create your own, you can. And we'll just begin by getting right into it, Chris. We begin by always developing a series of examples and non-examples for what we have in mind. In this particular case, I'm not wouldn't tell the students, but I have the idea of a relationship in mind. And I have a set of images there that's an example of what I have in mind. We've got a lightning and a forest fire. And the other set is not an example of what I have in mind, the lightning and a person walking down the street. And so these would probably best be done by printing out maybe all the pictures and keeping up on the screen, because that with the concept attainment one, at the end of the day, what we want kids to look at all the yes things. What do all those things have in common? So they, hopefully in an ideal setting, they'd have a picture of the fire and the lightning, and now this plant and a watering can. What do those sets of images have in common? And why do the no's don't have, what are they missing? Why don't they have that thing? Why aren't they considered a yes? And so you can start seeing that there's certainly a connection between the sets of images and the yeses. They're somehow connected in some way. And that's really what we're trying to build on, is that whole idea of there's a connection or a relationship, which is simply a connection between two or more people or things. And then we can go back and look at the relationship and try to state, well, what is the relationship between a clown and a person smiling? Well, clowns make people laugh. Perhaps that's the relationship. So to deepen that a little bit more, we go on to a couple more just activities built in. We can give them images or instances or contexts to say, is there an example of a relationship here? Where is it? What do you see? Why is it? What is the relationship? So students might point out to the two people on the left-hand side and go, that's a better example of a relationship there, because we can see that the guy and the girl are in a close relationship with each other. They're holding hands. So the descriptor there is a close relationship. So we can keep on exploring all kinds of things. In this particular case, I have an image you may not be able to see very clearly, but there are two people in the foreground planting a tree. And the statement reads, what relationship between humans and nature exists in this picture? And you notice I put a connecting line this time and a word, and those are just graphic ways of reminding students that when you're connecting aligned things, for example, we're building concept maps later, when you take two ideas and connect them, that line means there's a relationship there. And in this particular case, that picture shows humans helping nature, not hurting. And it's similar with the next slide. A different kind of a relationship, but we have this time humans hurting nature. And we keep on developing that whole sense of things that we're giving them a bit more independence. Is there a relationship here? If so, what two things are in a relationship, and what is that relationship? Let's state what that relationship might be. And so we're just continuing giving kids more and more practice in knowing what a relationship is, building it and stating it, and using a graphic way to demonstrate their understanding of that relationship. We can keep on going, Chris. It just gives all kinds of examples. I think you can keep on going through the end. It just really deepens that whole understanding. So concept attainment lesson basically is giving students examples and non-examples, helping them, giving them an opportunity to try to understand or develop a hypothesis of what that thing is by focusing on the attributes. And then finding more examples in their world. So you'll find those at the surface level activities throughout. Again, they're not going to necessarily have the idea memorized after one of these activities. This is just a way of introducing it at the surface level, and then keep coming back to it through more examples and have students deepen that. I mentioned that again, one of the verbs that were mentioned in the skills and procedures for this cup was represent. There's all kinds of representations that can be done. It's just a different way to demonstrate what we understand about something, or to communicate it so that people can understand it better. Those are all some representation ideas. There's tons of them. You'll notice at the bottom left-hand corner, I have a computational artifact. We'll talk about this later, but that's one of the a representation that can be done in grade 5. That comes from your grade 5 computer science, where they are starting to make computational artifacts by doing some basic coding. So what they end up coding becomes a computational artifact. So that too can become a representation. But again, whatever you're going to do, you want to make sure that they've had practice in making that representation. So when they do it, to demonstrate their understanding at the end. And there's some other things that you'll have. These are some concepts that kind of show up when in discussions and things like that. the concept impact is one that shows up quite a bit in grade 4 and grade 5 and grade 6. And so there will be some lessons you'll have available to you if you want to even just look at for yourself or to use to introduce those concepts to your class, because they do become, they're used quite a bit as the next through the rest of the organizing ideas at the rest of the grades. So finally, we get to the deep. Just get the bottom left. We've worked with all those individual concepts and those skills of represent, relate, and describe. And now when we're at the deep, we take a look at that understanding, and we take and then we look at the skills and procedures. Which one of those skills and procedures can we use to help develop that understanding? And so it may be to relate the movement and arrangement of particles to their state. We can maybe perhaps build a concept map or do something like that, or describing the impacts of the attractive forces that happen on the movement and arrangement of particles. And it's, building those diagrams perhaps that Chris had a slide on with the images with things compacted together and things kind of spread apart a little bit. So the key with the deep level is that we can introduce it in a context, and we can keep on using a similar kind of activity in a different context to revisit that understanding in multiple different ways. And that's why you'll see at the bottom of this slide the understanding, which is represented by the 3 concepts held together. The background represents a different context or different situation in which students are examining that understanding. So that's when we start providing those kind of contexts, we're deepening their understanding of those. So, and again, once again, Chris has some activities that will work you through the deep level.
So again, just some trying to find things that, if it's nice, that you could definitely do outside with students, but to give them something that they would relate to. So in this case, just relate your understanding of particle movement to a baseball bat, and in this case, water balloons. And then if you feel energetic, then go out and have a water balloon fight with the kids too, and have that conversation. But we want them to understand that there are things that they see every day, and how would they compare them, and how would they describe them, and which ones eventually, when we talk about density, which ones are more dense, and why are they more dense, and how could they explain that? So, if you have a cafeteria, when they go and sit down on a chair versus, a piece of a napkin, like, what's the difference? So again, having that conversation with students and making them aware of what they're seeing day by day in that term of explanation and the terminology that we're asking them to look at, that's going to get them to a deeper level. And that gives me an opportunity for them to even choose how they're going to describe their learning and their understanding to us.
And then after doing those kinds of activities that Chris had people doing more hands-on, again, you can have them, test their understanding to see if this all really fits. One of those activities, the hexagonal thinking, it's got to do with that relationship building that we just talked about. But in this particular case, you can see the considerations for that. Each of those concepts will be separated out, perhaps on a piece of paper, and then students start connecting them up to each other. But when they make a connection, they have to explain why that connection exists. So in this particular case, you can see state is connected to 3 things: solid, liquid, and gas. And it would be, students would have to explain that matter exists in 3 different states: solid, liquid, and gas, and why is helium connected to gas, and so on. So here's an activity to maybe help develop those relationships between all the ideas taken in this cusp line will be to pair students. And then you'll see in the next couple of slides, there are 2 slides with sets of hexagons. Some of the hexagons are similar and different because the intent is to give one student a set of these and another student a set of these, and then have them come together and combine them. And because some of the hexagons are the same in each one, we'll have to talk about how which ones they're going to eliminate and which ones they're going to combine together on their one, so that they create one understanding of all the particle matter theory concepts. And if they could put them together and demonstrate that to you, that really gives you a good indication of where they're at with their understanding of the particle theory. They can't do that if they don't understand those individual concepts, let's put it that way. So we're moving on to the next cusp line. Once again, there's a couple things in here. One is that if we take a look at one of the statements that the greater the mass, solid or liquid of a gas, as compared to its volume, the higher its density. That, and again, is moving into the understanding zone as well a little bit. So it's one that we're kind of sliding over and working with that, because you can do a lot with that to understand that in a variety of ways. And of course, the key concepts of state, mass, volume, density, compressibility, and physical properties there. So we look at the understandings like we did last time, and we pull them out, and we pull out the key verbs from the skills and procedure that we're going to use, and we begin at the surface level again. So the next graphic will show how we pulled those out. I didn't draw the arrows to the surface graphic, but those are the things we'll want to focus on at the surface level. Make sure that students know what mass is, what volume is, compressibility is. Property, they should know already. Particle movement and arrangement and particles, they should already know from the previous cusp. We're bringing those forward as well. So there's some new ones there as well. If they're going to be doing some measuring with the balance scales and whatnot, we'll want to make sure that they know how to use those tools. They understand the safety and practice rules as well. So you can see that comparing and relating are a couple of the key, again, kind of thinking skills that are going to be used for students to demonstrate what they know at the end of the whole cusp. So those things you want to make sure at the surface level that students understand those as well and have had practice in it. And if they already have that skill, then we don't have to necessarily worry about it at the surface level. So again, some more activities of how we can unpack some of these surface things. Once again, there'll be some links there for you to look at. We talked about similarity and difference a lot, just in case, just to help students figure out a little bit better the concept attainment there. Using the Venn diagram is really powerful, as Chris mentioned, for comparing and contrasting. Sometimes a table comes in handy as well, and that compare contrast goes through a skills teaching strategy or a step-by-step approach, how to perhaps help students make a comparison and contrast using criteria in their comparison and contrast. And typically properties become the criteria that we're working at. And again, using tools is something else that we saw in the right-hand side under some of the specific things kids need to do. So again, it'd be at that surface level when they're practicing using balance tools and other tools, that they'll understand how to use them and understand, of course, the safety procedures along with them, so that when they do it independently, they've got those things. Chris is there's a lot of the concepts in here, such as mass, density, volume, compressibility, and so on. Chris is going to share some examples with you as well. But I just wanted to point out with you in this particular case, if you look to the left, there's two things there called the Freyer model and the state, expand, exemplify, illustrate. Those are just two ways you might have students keep track of the different concepts that you have and to help them understand what they are so they can refer back to them. Chris, you could just click on one of those, either the Freyer model. Sure, okay. Click on that one. And they're blank, and all we do is have students fill it in. They have the definition of the concept. They write it in the middle. What are the attributes? What makes density density, for example? They can provide examples of the concept. They put it down there, and then non-examples of the concept. So there's that template there to work with. You may find that handy. Again, it's given that example and the non-example of the concept and distinguishing that. That is really the telltale whether students really understand the concept, because we can memorize the definition, but when we give them a new context to separate out the concept from the non-concept, that's when we know they deeply understand that whole concept. Chris, maybe I'm just going to have you go through property, because that property is such an important one. As Chris mentioned, it's a really tough one for kids to distinguish when you're talking about the property, describing things. So when we're asking them, for example, to let's say make a comparison contrast chart and focus on the properties or the physical properties, some of them may be tempted to write as criteria, how heavy things are, or grams or pounds or something. The idea of the property is just so important for so many reasons. So let's just take a quick look at it. Again, it's a concept attainment lesson. Students, they need to know what senses are, object and observation is, and description, because those are used in part of the understanding what a property is. I wanted to go through it all I won't go through it all, but just to give you a sense of what's in this. The non-examples and examples here, just like, once again, sets of statements, and it goes through each of the senses for each of those. So obviously we're going to the sense of sight here, but there's some statements there that refer to property, and other statements are not referring to property. So the object is a shape, a color, and a texture. To say that the object is square, brown, and smooth doesn't refer to, is not a property statement, so to speak, whereas the other ones are. And there's an example like that for each of the senses. And as our concept attainment activity goes, we go through a lot of examples and non-examples. Once again, if these would be posted so people can see them, we would finally come to a tester and see what everybody thinks about what some non-designated examples are. And I think it's in a couple slides away. If you can keep on going, Chris, right. So finally we get to what it is, the properties that objects have, characteristics that we can describe at the end of the day. And this is really at a younger grade level, but I think it really helps understand, help kids who have a difficulty understanding what a property is, to get a little bit clarity with it. And again, like the other concept attainment activity, we just go through now having them test it, providing examples of property versus a description and so on. You can just go to the next slide and you can see one example of what I mean by that. So we've got a campfire here, and then students now distinguish between the example of a statement that reflects a property and one that doesn't reflect a property. And once again, this is just an introductory activity. And once students have a really beginning understanding it, we keep coming back to it and building on and referring to that understanding of property with them. We can move out of that, Chris, and go to the slide deck now. So it's, again, those are things that we want kids to understand at the surface level at the beginning before we move on, so that when they could start using those concepts when we're talking, when we build them into the understanding. And once again, here's other ways to introduce those other concepts that were on that list.
So this really is just a slide full of opportunities for you to make sure that they understand, but one at a time, what mass is, what volume is, what density is. What are the differences between those? Because that's going to be critical for me to understand density if I don't understand mass and volume. So that's an important piece. Again, what do we mean by compressibility? So this is that surface level. Learn the knowledge first before you ask me to compare two particular objects that you give me, and make statements about what we just saw, for example, between them. So that's going to be really important for them to understand these pieces. So again, you may not need all of these. I'm just giving you a whole bunch of them here, but you may not need all of them if the students already have some good background knowledge, but that's that pre-assessment that we're going to have to do. There's additional resources in here too that you can click on without me going into all of them. So again, a slide deck of, first of all, the knowledge piece before we get into the deep piece. And if we need a review of states of particle matter and then combine it with the volume, with attractive forces, how do I talk about density? Like this page here really kind of pulls it all together for you. So I'm a person who likes to teach something to students. I usually grab from a story. I'll do a case study with them. I might do a video. And between all of those three things, we start to pull out what have we heard? What have we seen? What have we learned from this? And then I can figure out where their gaps still are, and then we fill them in. But as we start moving through them, I might want to review every morning or every afternoon that they come to me. I might want to have just a 5-minute of review, because each time you show me something different, a different video, there will always be something new, a different perspective, a different way of presenting it. And so again, these would be some of those places where I could go to and do that. Again, measuring volume. For some students who do baking, right? Even measuring volume in baking is a no-brainer for them, but not every child's ever baked before. So when do I measure something that's other than using a beaker in a science lab? That would be a great question to ask. Where have you ever measured something? And they might say, well, we make lemonade. What do you use to measure? right? Measuring cup, what's on the measuring cup? Like, what's the difference between a measuring cup and a beaker, right? Just something as simple as that. It seems like every child should know, but not every child's ever seen one. Not every child's ever seen a measuring cup before. So giving them those opportunities to have that conversation. And then again, find the mass of an object using a balance scale. They should have used a balance scale in previous grades, especially in math. They would have used a balance scale in grade 4 math as well. But again, it depends on how the teacher unpacked that, may or may not make the connection here. So always make sure that we don't assume that they know it, even though it might have been in somebody else's curriculum. Let's not assume that they arrived at our doorstep with that, for sure. And then how do I use my learning to measure with the volume, let's say, of water, or my beaker, or my measuring cup? How do I know how much I'm baking? How do I know if I have a half a cup of something? I don't have something to measure half a cup of margarine. So how do they measure that, right? How do I use liquid or water inside of a measuring cup to tell me that I have a half a cup of butter, or 250 mils if that's where you want to go? So, right. So it just, again, it's the practicality of it. Have some fun with it, maybe build a little baking project that happens with the kids at the same time so that they get the hands-on learning at the same time.
How do you measure?
Sorry, all of these always start as soon as we move forward. So now, assuming we have all of that terminology, I'll let Ted jump in.
Yeah, yeah, and now we're going, so after all that terminology, once again, we skipped a slide, but you'll see it on slide deck. Just don't go back, Chris. We're now moved into the deep component. Now we're starting again, putting those individual things together, those individual ideas and thoughts. And so this is one thing you may want to do. There's this little video there that shows, when you drop an ice cube in water, the ice cube floats, but when the ice cube starts melting, of course, the water sinks to the bottom. So that helps to develop that whole sense of what's the relationship between density, volume, and mass. What you want to do, of course, is just when you're planning for this, if you're going to freeze things, draw a line where you're freezing things to show to students later on that it's the same water, it's just a same amount of water, just a larger volume than it was in its original form. When it gets to matter expanding and contracting, that gets into grade 6. You may want to touch bases on it now. But at the end of the day, it's after doing that experiment with the kids, or that demonstrating with the students, it's really, what you could do is just have them explain what they see, why is that happening, and using perhaps some of the words there that might help them understand, to demonstrate why the water is sinking, again related to the idea of density and volume and so on. But just a little fun one you might want to try.
Do you want me to go back one?
Nope, that's good. We can move forward.
So one of the things that we did do in the pilot is we had invited ExploreNet Learning to join us for the grade 5 and 6 presentations. And the purpose of that was twofold. One, if you are not familiar with gizmos, then we would encourage you to make sure that you sign up for one of the short 45-minute training sessions. Just once is all you need to go. But they're held by ExploreNet Learning as well through all of the consortia pretty much. You can have them come to your school for free. They'll work with your staff. It doesn't have to be everybody. But the purpose of a gizmo, or what a gizmo is, if you're not familiar with it, it's a very interactive learning opportunity for students. And because there are so many of them available in the science, we really asked for them to come on and maybe make some linkages for us between the gizmos that currently reside on the site and what do they link to as far as our curriculum is concerned. Now, this comes from ExploreNet Learning. You're going to see 1.4 and 1.3 here. Just look at the outcome, because that really was linked to the old pilot, and we used to have 4 different sections in this particular area. But you have a gizmo that covers a lot of material that we're talking about here. And again, they're very interactive. When you use a gizmo, if you've never done one before, as a teacher, you want to go in and do the gizmo first yourself. Like, make yourself completely familiar with it, pull off whatever worksheets they have and student resources that they're going to share with you, because it's all for free. So you want you to grab that material first and go through it. and then bring it up to the students. So they'll need a personal device like a Chromebook or whatever that they're going to use, but they need an opportunity. They can work in pairs, and it's usually gives you a good time frame on there as well. There's one called the Secret Service. They have kind of like a mini task at the end of all of this stuff once we kind of get through it. Secret Service is a really neat one because they have some coins in there and the students have to figure out something about the coins, where it was from, and they're going to use all of their knowledge that they just got in this unit to do that. So if you haven't done that and you're not sure how to sign up for one of those, please just make sure that you email either Ted and I, and we can give you a hand with that. You do have access to gizmos through the New Learn Alberta site, but you have access to just the ones that are posted there. There is a whole website of them that you can access if you get your login through ExploreNet Learning. So having both is definitely an advantage, but gizmos are great. Oh, you're muted.
I am. So what we've just finished is taking you through the 2 cusp lines in the grade 5 matter organizing idea, going through some surface level activities, deep, and now we're at that transfer phase. And really it's that transfer phase where we also could really do our assessment, because transfer simply means giving students a new context to use their and apply their skills and understandings independently. So a way we can assess at the different levels is, once again, triangulation is always a helpful way. We can do that for our formative assessments along the way to make sure that students are showing an understanding of the concepts and the knowledge of the skills by observing, having conversations with them, and seeing what they're producing. And as I mentioned in this slide deck right here at this bottom here, that transfer activities can be those summative assessments as well. You can take the skills and procedures statements and turn those into assessments, either summative if there's a new context with them, or you can use them as formative assessments. But when you do that, and you click, Chris, if you could click on that link for me, please.
Oh, sorry.
That's all right. What you want to do is just line up the skills with the skills and procedure statement with whatever it's assessing. So you'll have a link to this, but you could see that there's things that are gold or the orange. They link to the understandings. And if we do something with, like, for example, representing solids, liquids, and gases using the particle theory of matter, you're representing their knowledge of that. So that's a pretty surfacey level kind of activity there as well. And when you go through the cusp lines, if you could scroll down, you'll see that the skills and procedures statement is hooked up with either the understanding or something in the knowledge piece. If it's black, that means there's nothing in the skills and procedure statement that really can be used as an assessment for understanding that. For example, do students know what the SI units are and how they're abbreviated? Well, that's a knowledge thing, and you'd assess that or see that in their own way. If you see the colors that are kind of differently shaded, those would link up. You'll find a match somewhere on the left. So the light blues will all link together for the same kind of piece of knowledge along the way. So you see anything in a blue, it's the knowledge or the surface. Different shades of blue just helps you to connect up with the actual statement on the knowledge side of the procedure there. It just might be helpful when you're assessing to see what kind of which statement lines up with which, so you can plan your assessments that way. I do want to point out one other thing with this document. If you go to the top, please. Yeah, right there, you'll see if we move away from the knowledge, understanding, and the skills, we'll see the next column is the overall grade 5 science verbs. What I've done is taken every skills and procedures statement in grade 5 from all the cusp or all the organizing ideas, so every one of them, and found the frequency of the verbs used in the skills and procedures. And you'll see that they're listed there. There's not a whole lot. And you could use probably any of those verbs to create assessment activities for yourself and for your students. So instead of representing, you could have explain, or you could have discuss, and kids can discuss things in a variety of ways. We know there's think, pair, share, there's four corners, there's gallery walks, and so on. So you could use any of those, because at the end of the day, the skills and procedures, those statements are what students do. They do any of those things to demonstrate what they know and understand. And when they demonstrate what they know and understand, we can make some assessment about that. So that's just there for your reference as well. Computer science and scientific methods, things are there as well, because any of those could be integrated, but I won't go into those because we have a couple slide decks that go into those a little bit further. But again, those could be used along the way for assessments as well. Because making predictions is another thing you could use, right? It's a step in the scientific method, but you can see how you can use making predictions as a way for students to demonstrate their understanding of any of this. And then to the next slide, again, so when you use your skills and procedures assessments, you can use those. For example, we have one that says directly compare the density of solid objects that have the same volume. But if we just do it at that, we're gonna know that the students compare and contrast, and they'll know that they can identify similarities between them. So if you go to the next slide, Chris, we just want to make sure that if you want to make sure it's a deeper assessment, you want to make sure you ask questions for kids to relate. So if they were doing that activity, they might fill in this kind of a chart. But you can see the questions at the bottom are really the ones that help take this to either a summative assessment, which would be a transfer assessment, or a deep assessment for the CUSP itself. And you could see that not only students will they identify some of the similarities between different objects based on volume, mass, and density, but then there's some questions that have them think about it. For example, what can you conclude about the relationship between volume, mass, and density based on this? So we'll see that the volume's the same, the mass is different, and then when they do there, fill it in, and they'll see that the density is different. What does that tell you about that relationship between those three things, or those three concepts? And again, second questions are there as well, just to help kids go a little bit deeper with their understanding. So yeah, go ahead, take those skills and procedure statement, but you can see you can add on different questions to go along with it to deepen it. And again, the next slide is just another example of how you can deepen that. So we won't have to spend time on that. It's doing something, but explaining how you know it is really what it boils down to.
And when you go through that interactive lesson that I showed you at the very beginning, where I said it kind of covers the whole outcome, you'll find those diagrams in there. So this would be a great culminating piece to that, just to verify that they understood it. But they will have interactive links in there to do each one of them independently. So doing the solid, the liquid, and the gas, so that they can actually see how they fit together.
Great.
Okay, we've already talked about this one, so I'm going to leave that one out. And then just some resources, again, that you would have access to or could have access to that fit with what you're studying with the students right now. The Nature of Matter is a good one. It fits to the majority of what you're talking about in your particular organizing idea. You've talked about this one already. And then I've just got some sources on here. Fuse is a science resource from Australia, and they have lots of tasks that you have access to and videos. So you might want to check that out if you were looking maybe for something a little bit different, and you want to give students choice. So well, here you could give me 3 different tasks, and I have to explain whatever it is you want me to do in terms of light of the particle theory matters. So again, you've got some opportunities there and things, and this is that Science Flex series that I was talking about as well. Okay, there is a number of those little books that I've been showing you. Some of them come directly from the Spark Library for Pearson. Some of them we've ordered, and we're just reading them to see if we can find some books that would be good sources for you. But Pearson does offer you, it is one of those ones where you subscribe to and pay for their library services. But you have 30 days to go through and at least read some of the books to see what would be a good match for you, or maybe you're just looking for a couple, just to see what's out there. I mean, there's no requirement for you to stay on. You don't have to subscribe. There's no, deposit or anything up front. You just have a 30-day free trial, and you can have a look at what's in the library. And that's how I found a lot of the books to start with. So we mentioned that Ange Deering was one of the teachers that has come on board with us. She is the Ed Tech representative from Wetaskiwin Regional Public Schools. And Ange has created for you a computing science. You'll see it says 11 minutes in there. So when you come in here, you'll get this recording, the slide deck. You can just click them on. All of the links will be active in there. And she will go through specifically about what would it look like for computing science in grade 5 matter and give you some ideas of what to do with that. She also provides you with a copy of her slide deck. So if there's anything there that you want to use or have a look at, then you're welcome to use that. And equally as well, when we talk about the scientific methods. So Nicole will be posting them and putting them onto the grade 5 site. So you'll be able to find them there and have opportunities then to have a look at what that would look like. All right. And she's made some points in here already of grade 2 science. Ted, did you want to have anything to say on that one?
Just only that when you go to, if you don't get to any of Nicole Ammer's recordings, to help you with that, the investigative procedure is the same for grade 2 and up. So you won't find that listed in the grade 5 scientific methods. It's found in grade 2. But anytime you see the word investigate in the skills and procedure and one of those things to do, you have to go back to grade 2 to get those steps. And so that's the grade 2. When you get to grade 5, you can see the focus is on investigating phenomena using investigations, so scientific methods. And the focus one of the steps it's focused on is just what is evidence when you gather all that data, how do we turn that data into evidence to make our conclusion, introduce a bias. And of course, at grade 5 level, the one of the investigations is a controlled experiment and taking a look at how variables come into play in a controlled experiment. So it deepens up a little bit, but those same steps are in grade 2. You have to go back and look for them.
And you can guess what we told the grade 2 teachers, that they are super important. They got to make sure the kids know that because it affects everybody after them. So yes, while we're bridging in the first couple of years here, we're going to have to make sure we go back and grab that. You have access to everything that is in the site. So let's first of all, before we ask for any questions, and I'll stop the recording when we ask questions so that you're not conscious of everybody listening. But let's go to the site first to make sure that everybody's aware of where to find it. And we'll do that right on the recording. So in the chat box right now, and I think Ted already put it in, but in case you missed it, it's arpdc.ab.ca. So I'll bring it up on my screen here. So when you come here, you're brought to the original ARPDC site. You want to come up top here where it says new curriculum resources, if this is where you end up, and just click that on. And then you can select, what is the subject matter that you want to go to. Remember, there's nothing new in social studies at the moment. So we're going to go to science. And here you can either just stop here, and what will happen is anything that's new, if you're just going to stay in the general site, whatever the most recent posting is what will be at the top. But that means you're going to be scrolling and scrolling and scrolling and scrolling. So let's minimize that by saying I want science. I want to go to grade 5, and we can leave it as all because you just want to see it's there. So you see already that Living Systems has been posted. You will see one shortly, probably tomorrow, that will be called grade 5 matter. And so when you want to go into any of these, you can see the resources that are below. When you click on a resource link, for example, you have the video that we just showed you. You'll have the slide deck that you can access. You have additional slides, assessments, and resources. So anything that we found or anything that we showed you or the concept attainment links that Ted was showing you are all built into one of these slide decks or one of these folders here. When you click on a folder, it will download it for you. It's a zip file, and then you can save it to your file, your computer, whatever. But you have access to this anytime, any place that you need. And that means that if you saw something, heard something, oh, I needed that from grade 3, well, then you can go into grade 3 and just select what from whatever topic, matter, or was it living system that you needed it from. Just an FYI again, if you are in any way using the old materials, because they are still posted, as we post new ones, we're taking the old ones down. But if by chance you happen to go into, oops, I should go probably limit mine here. So all of your key documents that you talked about in video 1, if you haven't done video 1 yet, this is where you're going to find those. They're also linked in that presentation. But if you do go to any of the ones here, like energy, for example, you'll see that it says draft. And that is based on the old draft curriculum, which has now changed, as you saw in Gizmos. There used to be 4 sections to the one that you're doing now. So the outcomes don't match any longer. So if you are going to use anything at all from those, you will have to go back and match them. When we redo energy, according to the new curriculum document, then this one will be taken down. We'll take from there whatever we think is relevant. We'll add in new pieces. So it'll be a completely up-to-date one. So just an FYI for you there. Okay, so that's how you can find all of your resources at any time. All right, let me just stop our recording.